Hello everyone, welcome to the second episode of Trigonometry for Olympiads. This is particularly useful if you are preparing for IOQM, INMO or the American math competitions. This is episode 2, so you can start with episode 1. The link is in the description. Today, we will talk about the table that we started constructing in the last class. This is known as the table of Aryabhatta. So what it does is, it takes a unit circle. This is a unit circle. Unit circle means the radius is 1. And then it compares arc length with chord length. The fun fact is, the arc length is given as a proportion of the circumference. So it's not actually giving you the length of the arc. It's telling you what proportion of the entire circumference this arc is. Maybe it says that it's 1/5 of the entire circumference. Then the mission is to find the length of the corresponding chord. What is the length of the chord from A to B? It could be the other way around. I tell you the length of the chord, maybe the length of the chord is 1/7. And then I ask you what proportion of the circumference. So the length of this chord is 1/7 xy. And I ask you what proportion of the circumference does the end point of the chord subtend. So the arc from the end points of the chord, what proportion of the entire circumference is that? So it can go both way. And we saw in the last video that if, so I'll draw the circle one more time. If the length of the arc AB, if the length of the arc is 1/6 of the circumference, 1/6 of the circumference, then the length of the corresponding chord is 1. So the chord length is 1. This is a property of the circle. Of course, it's happening again, I remind you, it's happening in a unit circle. Now let's derive some more values of this table of Aryabhatta. So we will actually update the table a little bit. Instead of talking about the full chord and the full arc, we will talk about the half chord and the half arc. Half chord and the half arc. So what is the half chord? So let's mark the center O and let's drop a perpendicular from the center to the circumference. Then the half chord is this much, the length of AT. Let's call this point T. And the half arc is AM. The half arc is AM. So notice that the half chord is not really a chord, it's just half of the full chord. Because if it has to be a chord, then both the endpoints should be on the circumference. That doesn't happen here. But the half arc is really an arc. Okay, so why do we sort of do this? Because if we know the half chord and the half arc, then we can just double it to know the length of the full chord and the full arc. And more importantly, what we can use here, if I join OA, I can now use the Pythagoras theorem about right angle triangles. Because this angle, since I dropped a perpendicular, is right 90 degree. So half arc is 1/12th of the circumference, and half chord is of course 1/2, right? If half arc is 1/12th, that is half of 1/6, 1/12th of the circumference, then half chord is just 1/2 because the full thing is 1. This part you have to understand very carefully. Next, let's do a little bit more calculation. What if the half arc is 1/6 of the circumference? What if the half arc is 1/6 of the circumference? That means the full arc, this is in our mind, we will sort of calculate it in our mind, then the full arc must be 1/3 of the circumference. So we have to divide the circle into 3 parts. And we want to know the half chord length. So let's do the calculation. Let's draw the circle one more time. We know that if I have unit radius circle and if the length of these chords are 1, then 2 of them will cover 1/3 of the circumference because 6 of them covers the entire circumference, right? So therefore this is 1/3 of the circumference. 1/3 of the circumference. In other words, if I join these, then this AB is the full chord. AB is the full chord and AB is the full arc, right? Okay. So if that's true, then let me shade the half arc. This is the half chord, and this is the half arc. So what is the length of this half chord? What is the length of this half chord? If this entire half arc, if this entire arc is 1/3 of the circumference, the half arc is 1/6 of the circumference. That's what we want. So what is the half chord? So let's calculate. We know that this is 1 and this is 1 because both of them are radius, and this is 1 because this is 1/6 of the circumference. So this chord is 1. This we deduced from the previous video. And by symmetry, this is just a perpendicular of an equilateral triangle, a perpendicular bisector. So this little portion is half. So if this is half and this is 1, then this much is just Pythagoras theorem, square root of 1 square minus half square, which is square root of 3/2. That's the length of the half chord. Square root of 3/2. Okay, let's do a little better. What if the half arc is 1/4 is 1/4 of the circumference? What if the half arc is 1/4 of the circumference? So let's draw this. So let's draw the circle again. So let's cut it into 4 parts. Let's cut it into 4 parts. This is the full arc. This is the full arc, which is 1/2 of the circumference. It's just a semicircle. That means this is the full chord, which is the diameter, whose length is 2, because we are in a unit radius circle. That means this much is the half chord. This much is the half chord. And this much is the half arc, which is our 1/4 of the circumference, which is what we want. Okay, so then the half chord is just the radius, which is turning out to be 1. Very nice. So we are making progress. We are making the table that Aryabhatta did about 1500 years ago. Let's make another entry of this table. Let's make another entry of this table. Let's make 1/8 of the circumference. 1/8 of the circumference. If the half arc is 1/8 of the circumference, then what is the half chord? So let's draw the picture one more time. I'll draw here only, so you can sort of compare and see what's going on. This is the sort of the 4 quadrants in which I divide the circle. Now, this entire thing is 1/4 of the circumference. 1/4 of the circumference, which is great. We want 1/8 of the circumference, so half of that. So we want half of that. Let's call this point A, this point B. Then AB is the full chord. Full chord. And the arc AB is the full arc. So what we are interested in? We are interested in the half chord and the half arc. Half arc and the half chord. Again, we can use Pythagoras theorem. If this is 1 and this is 1, then AB is square root of 1 square plus 1 square, which is square root of 2. And AT, the half chord, is just half of that. So AT is simply square root of 2 over 2 or 1 by square root of 2. Right? So that is my half chord. So I write it as 1 by square root of 2. 1 by square root of 2. So one of the things that I should probably tell you as a historical remark, that this half chord is sometimes known as ardhajya. Ardhajya in Indian parlance or Hindi or Sanskrit maybe is half of a bowstring. Half of a bowstring. So if you look at this much, this looks like a bow, and this half chord looks like a half of a bowstring, right? This entire thing is the bowstring. So this looks like half of the bowstring. So Ardhajya, this is how Aryabhatta coined the term, and then it traveled to the Arabs, and then it traveled to Europe, where it got the name sine. So what we have essentially done is created a table for something called the sine function. So what is the sine function? Sine function takes input of the half arc length and gives output as the half chord length. That's what sine function does. Sometimes in some trigonometry books, they start with a right angle triangle, and then, they talk about sine and cosine and so on. But the real thing that is going behind it, the reason you need a right angle triangle is because they were trying to compute full arcs and full chords. They found that it is sufficient to compute half arcs and half chords, and when they did that, they found a right angle. They ended up with a right angle triangle here. That's the reason you start with a right angle triangle sometimes in a trigonometry textbook. So this half arc length, sometimes the full arc circle circumference represents full rotation, which is encoded as 360 degree. It's like 360 days of the movement of the sun in the night sky, in the day sky. The entire circular rotation is 360 degrees, which means that 1/12 of it is 30 degrees, 1/6 of it is 60 degrees, 1/4 of it is 90 degrees, and 1/8 of it is 45 degrees. So you get a input output machine, which when you input 30 degrees, you get half. So when you input 30 degrees, you get half, that is the half chord length. When you input 45 degrees, you get 1 over root 2. When you input 60 degrees, you get root 3 by 2. And when you input 90 degrees, you get 1. These are some of the values of the infinite table that is supposed to contain all the half arcs and all the half chords. And then there are certain values which cannot be computed in the way we have done using Pythagoras theorem. So we have started on with trigonometry, and from the scratch, from geometry, we deduced the sine function, which takes input as arc lengths, half arc lengths, and gives output as half chord lengths. In the next episode, we will derive the other trigonometric functions and talk about more interesting tools in trigonometry that are needed to get a very good understanding of the fundamentals. Thank you for staying with this video, and I will see you in the next one. Bye.